Welcome back. Thank you for joining me. So today we're going to talk about two polynomial theorems. All right. The first polynomial theorem we're going to reference is called the rational root theorem. So what that says is any possible rational root of a polynomial will be the factors of the constant term divided by the factors of the leading coefficients. So more visually, any rational root has to be a factor of a constant term divided by a factor of the leading coefficient. Now, what this looks like. So for this polynomial right here, I take the factors of the leading coefficient, so the factors of 2, which are just plus or minus 1, plus or minus 2. Then the factors of 5, which are just plus or minus 1, plus or minus 5. And then I start running through my options. So factors of the constant divided by factors of the leading coefficient. So 1 over 1, 5 over 1, 1 over 2, and 5 over 2. That's where they're getting that list from, okay? Just taking the possible ones of the constant, dividing by the possible factors of the leading coefficient. And why is this useful? Well, this is useful because if you're searching for rational roots, it gives you a starting point because you know with certainty that those are the only possibilities for rational roots. So it gives you a start when you're looking for the zeros of a polynomial. So the stuff that we were doing way back when, it gives you a starting point to know where to start looking. Okay, so I want to take a look at these now. So I'm going to start to find the possible rational roots. I'm going to take that 3. So the factors are plus or minus 1, plus or minus 3. And then the factors of negative 10, which are going to be 1, 2, 5, and 10. And now I want to list out my possibilities. So I take 1 divided by 1. Well, that's just going to give me 1. 2 divided by 1, which is just 2. 5 divided by 1, which is just 5. 10 divided by 1, which is just 10. 1 divided by 3, which is 1/3. 2 divided by 3, which is 2/3. 5 divided by 3, which is 5/3. 10 divided by 3, which is 10/3. So again, just taking every combination that you can of taking those from the list in the blue, dividing it by the list in the green. All right, so let's try this again. So for my possible rational roots, 4 has 1, 2, and 4. 6 has 1, 2, 3, and 6. And now I'm going to start searching through my possibilities. Well, 1 divided by 1 is just 1. 2 divided by 1 is 2. 3 divided by 1 is 3. 6 divided by 1 is 6. So I've exhausted all my options for that 1. So I'm going to move on to 2. Oh, I'm sorry. I crossed off the wrong one. I used up that one. So now, 1 divided by 2 is going to be 1/2. Well, 2 divided by 2, we already have that. 2 divided by 2 is 1. So I'm not going to include the same thing on my list a second time. So I'm just going to move on to the 3. 3 divided by 2 works. And then 6 divided by 2, well, 6 divided by 2 is 3. That's already on our list again, so I'm not going to write it a second time. So now I've exhausted those. I have 1 divided by 4. 2 divided by 4. Well, 2 divided by 4 is 1/2. Again, it's one that we already have, so I'm not going to put it on our list again. 3 divided by 4. And then 6 divided by 4. Well, 6 divided by 4 is the same thing as 3/2. So again, I'm not going to list the same thing multiple times because that would just get repetitive. So that is my list for that polynomial of all the rational zeros. So if there is a rational zero, it must be one of the numbers on that list. Now, the theorem that I think is more important is the fundamental theorem of algebra, and our next 2 videos are going to focus on this theorem. Now, what it says is whatever the degree of the polynomial is, that's how many zeros it has, how many solutions it has. Now, the solutions can take different forms. Okay, so it can be 2 real solutions. Oh, okay, so here you have 2 real solutions. You have a quadratic, and so you just have 2 reals. Well, here I have 1, but it's a double solution. That's why we learned about the multiplicities back previously, because it counts as 2 solutions because it is a double solution. It has a multiplicity of 2. So that quadratic still has the 2 solutions that it shows since we're dealing with a squared polynomial. And this last one has no real solutions. However, what I want you to realize, that means that there's 2 imaginary solutions, 2 non-real solutions. So if you think about it, no matter what way you look at it, each of those has 2 solutions. All right? So that's important because that tells us how many things we're looking for, how many solutions we need for any given polynomial. So when I look at this, I want to know how many roots the polynomial has. When dealing with a cubic function, is going to have 3 solutions. When I'm looking at a quartic function, it means I have 4 solutions. So again, that's the power of this fundamental theorem of algebra, is it's telling you how many solutions you're looking for. Then paired with the rational root theorem, that gives you a starting point for finding those solutions. So these really work hand in hand to really help guide you to all of those zeros. In our next 2 videos, I'll be showing you how to find all of the zeros, what strategies you can use. So, as always, make sure you have all this written down, please, and come and see me if you have any questions still.